A very warm welcome to all my dear students of St. Joseph's Academy, Class 6th. In this video, we are going to study about magnetism. Here we are going to learn about the methods of making a magnet. We use 4 different methods to make a magnet. The first one is single touch method, double touch method, by magnetic induction, and we also make magnet by using electric current. Magnetic induction method. Take a long nail, put it on the arm of the stand, spread some pins on the base of the stand. It is seen that the pins do not get attracted onto the nail. So the first figure here, when the nail is there on the stand, here the nail is not having any magnetism, as a result of which the pins which are there at the base of the stand are not getting attracted to the nail. But when a magnet with one of its pole is brought near to the iron nail, here we can see that a south pole is generated at the top of the nail and a north pole is generated at the base of the nail. So here the magnet which is brought near to the nail is brought near with its north pole towards the nail. When the magnet is brought near to the nail, then the nail also acquires the property of magnetism, and we can see that some of the pins have been attracted towards the magnet. In the third case, when the magnet has been removed from its place, when the magnet has been removed, then again the pins fall back down on the stand, which shows that when we are removing the magnet from this position, then the magnetism which was produced in the nail has also been lost. So from this method we came to know that the magnetic induction method means that a magnetic material will behave as a magnet when it is in close contact with another magnet. On removal of the magnet, the magnetism of the nail is lost and it does not behave as a magnet anymore. Single touch method is one of the various ways of making a magnetic material like soft iron into a magnet. In this method, one end of the magnet, say a north pole, is placed at one end, say end A of the iron piece, and then rubbed over the bar from end to other, say end B, then lifted and brought back to the first end. The another method of making a magnet is known as single touch method. The name single touch has been used because here we are using a single magnet which is taken in contact with the steel bar or an iron bar, and along this line, which we can see in the dotted form, along this line the magnet is rubbed over the steel for around 20 times. Then again the steel bar or the iron bar is flipped over, and again the same process is repeated along the same dotted line. The process is again repeated for 20 times, and we notice that after the process has been repeated, now the demagnetized steel bar starts behaving like a magnet. So from this diagram we can understand that when the magnet is brought near to the demagnetized steel bar, the north pole and the south pole of each and every small atoms present in the iron bar or the steel bar is magnetized and is properly arranged in a particular direction, that is in the north and south direction. So as a result of which the demagnetized steel iron bar, upon repetition of the magnets over the steel bar, it also starts behaving like a magnet. Double touch method. From the figure we can see that two magnets are being used in order to make a bar into a magnet. The bar here we are using can be a steel bar or an iron bar. which is a demagnetized bar. The double touch method involves rubbing both the ends of the iron bar with a pair of bar magnets with the opposite poles on either side. This can make a stronger magnetized iron bar as compared to the magnet made by the single touch method. What is the difference between a single touch method and the double touch method? In the single touch method, the magnet is rubbed over the bar in the same direction. In double touch method of magnetizing an iron bar by simultaneously stroking it with the two opposite poles of bar magnets. Electrical method of making an electromagnet. In this method, we can see that a demagnetized iron nail is wound over by the insulated copper wires and is connected to a DC source. When the battery allows the flow of charge through it, when the electricity flows through the wire, then the demagnetized iron nail behaves like a magnet due to the generation of opposite poles on the two ends of the magnet. The end of the nail where the current enters anticlockwise direction that forms the north pole. The other end of the nail where the current goes clockwise that forms the south pole of the magnet. In this method, a ferromagnetic material is placed inside a solenoid and a direct current is passed into a solenoid using an insulated wire coiled into a cylinder, and it produces a strong magnetic field inside the coil which is uniform in strength and direction. This iron nail behaves like a magnet till the time the battery allows the flow of current in it. Once the current source is disconnected or the switch is open, then again the iron nail loses its magnetism. Magnets. What are the some uses of magnets? Magnets are used to make electric motors and generators. We use these electric motors and generators in telephones, lights, electric heat, television, and computers. Some items that use electromagnets are car crushers, scrap metal, sorters, maglev trains, computers, doorbells, tape recorders, telephones, etc. So with this we can see that the magnets form a very important part of our life. It is used in many toys, it is used in the refrigerator, it is used from a very small things to the very larger things to make our life comfortable. So magnets are in finds an immense use in our day-to-day life. Let us see some more examples where we can use magnet. From the two diagrams, we can understand the use of magnets. See, the magnets are used in the aeroplanes, as a chip inside the debit and the credit cards, inside the computers, in the toys, etc. The magnet is also used on the door of the refrigerator. Magnet is used for magnetic separation. Magnets are used in the doorbells. Magnets are used as the in the doorbells. Storage of magnets. We know that the magnet has a magnetism due to the property that in the magnet all the atoms are arranged in a particular direction. But if the magnets are left open into the space, then it loses its magnetism in the due course of time. So, it is very important to store the magnets in a proper way so as to retain the properties of the magnet. So one of the method of storing the magnet is by using the magnetic keepers. For the two different kinds of magnets, we can see that the two different arrangements are there for the storage. For a bar magnet, we can see that the first bar magnet is stored in the north and south direction. Then we have a wooden board in between the two magnets, and then the second bar magnet is stored with its south pole and north pole. So thus it forms a cycle, north-south, north-south. Thus the magnetic lines of force revolve around this only, and they do not lose the magnetism. On both the sides of the north pole and south pole of the bar magnets, we place iron bars. For a horseshoe magnet, where one end is south pole and another end is south north pole, both the ends are stored over a iron bar to prevent its magnetism. Store your magnets with a keeper. A keeper is a small piece of iron that is generally added temporarily between the north and south poles of a magnet. Store your magnets in pairs. Keep magnets in pairs to avoid both north and south sides from touching. Demagnetization of a magnet. Just now we learned that if the magnets are not properly stored inside the magnetic keepers, they will lose their magnetism. So here we can see that in a magnetized bar, the north pole and the south poles of the atoms inside the magnet are properly arranged in one direction. But for a demagnetized bar, we can see that each atom is randomly arranged so that the magnetism of one atom is cancelled by the magnetism of the other. As a result, the net magnetism in this is equal to 0. So to prevent the demagnetization of a magnet, it's very important to store the magnets properly. There are different ways by which we can destroy the magnetism of a magnet. First one, by hammering a magnet. When we hammer a magnet repeatedly, then the magnetism of the magnet is reduced because the arrangement of molecules or atoms inside the magnet is destroyed. The second method is by heating the magnet to a very high temperature. So if we heat the magnet to a very high temperature, it destroys the magnetic property of a magnet, as a result of which it is demagnetized. Another method of demagnetizing a magnet can be that we can throw the magnet on a rough surface from a height. If we will throw the magnet repeatedly on a rough surface from a certain height, it will reduce the magnetism of the magnet. So these are the certain ways in which we can demagnetize a magnet. So in order to prevent the magnetism of the magnet, we should avoid these practices. Now, temporary and permanent magnet. Temporary magnets are those magnets which loses their magnetic properties as soon as the magnetizing force is removed. This we saw just in the case of the magnetics induction, where the nail lost its magnetism when the magnet was removed from the side of the nail. Permanent magnets. These magnets do not lose their magnetic properties. Temporary magnet. It cannot convert an ordinary piece of iron into a magnet because of its weak power. Permanent magnet. It can convert an ordinary piece of iron into a temporary magnet. Temporary magnet. It is made up of soft iron, while permanent magnet is made up of steel, cobalt and nickel. Thank you everyone. Hope this video is helpful for you to understand the magnetism of the magnet. Have a nice day.